welcome to another tutorial video. In this video, we will be talking about standard form, also referred to as scientific notation. What is scientific notation or standard form? Scientific notation is a way that scientists easily handle very large numbers or very small numbers. For example, instead of writing 0.0000000056, we write 5.6 times 10 to the negative 9 power. We can think of 5.6 times 10 to the negative 9 power as the product of two numbers. 5.6 is referred to as the digit term, and 10 to the negative 9 power is referred to as the exponential term. Now let's look at some examples of numbers written in scientific notation. If we take, for example, 89 in scientific notation would be 8.9 times 10 to the first power, though this is not usually done. 482 in scientific notation is 4.82 times 10 squared. 7,354 in scientific notation is 7.354 times 10 cubed. 24,327 in scientific notation is 2.4327 times 10 to the fourth power. If we observe the pattern in these numbers closely, we will be able to derive how we go about writing numbers in scientific notation. Let us first observe that all numbers written in scientific notation have only one value to the left of the decimal point. This is one of the ultimate objectives that must be met in order to have successfully written a number given in ordinary form in scientific notation. Secondly, as was previously said, the second aspect of a number in scientific notation is that it is multiplied by a power of 10. Now, in 482, we would have moved decimal points 2 times, or we would have moved 2 digits to the right of decimal points in order to get it in the form 4.82. Therefore, to ensure that 482 maintains its value, it must be multiplied by 10 squared, because again, the decimal point was moved twice, or 2 digits were moved to the right of the decimal point. As is the case with 7,354, whereas in order to get 7 being the only number to the left of the decimal point, the decimal point would have been moved 3 places to the left, or the digits would have moved to the right. Digits would have been moved to the right. Therefore, 7,354, in order to ensure that it maintains the same value as 7,354, it is multiplied by 10 cubed. Let's look at some more practical examples. If, for example, we are given the question that says, write the number 412 in standard form, we can identify that the number 412 is in what is called ordinary form. It's an ordinary number, and we are being asked to write this number in standard form. The first step that we need to do in order to write 412 in standard form is that we must identify the position of the decimal point. Decimal point. It is important to note that the decimal point in any whole number is usually to the right of the last digit, which would be the digit in the ones place. Therefore, the decimal point in 412 will be to the right of the 2. I'm going to use the red pen to represent the decimal point. The second step that we would need to do is bearing in mind that the aim of writing a number in standard form is to get the only one digit to the left of the decimal point. We must now either move the decimal point in the appropriate direction to accomplish that objective, or move the digits in the appropriate direction to achieve that objective. In doing this, we will get 412, and remember our decimal point is here. So when we move the decimal point, in order to get only one digit to the left of the decimal point, we must move the decimal point to the right, as we currently have 3 digits to the left of the decimal point. So that will give 1, that's one step, and 2, which means our decimal point will end up here. Or if we had the same 412, and we know the decimal point is to the right of the 2, as it is as a whole number, we could move the digits of the number. So we would move the 2 and place it here, and we would move the 1 and place it here. Now please note that if you are doing the route of moving the digits, the digit that is closest to the decimal point will end up being farther away, and the digit that is farther away from the decimal point will end up being closer. So in this case, the 2 was closer to the decimal point before we moved it, and now when we moved it, it will be farther away from the decimal point. The 1 was further away before we moved the digit, and now it will end up being closer to the decimal point. So this will leave us with 4.12. So after we get only one digit to the left of the decimal point, we must multiply the digit term, which is the answer we got, by the power of 10 based on the number of times the point was moved. Having moved the decimal point or the digits and gotten 4.12, remember 4.12 does not have the same value as 412. So we must remember to also multiply it by the exponential term, which would be the power of 10 based on the number of times you move the point or the number of digits that you moved. So that would translate to 4.12 times 10 squared. The base of the exponential term will always be 10, but again, the power is determined by the number of times the point is moved or the number of digits moved. So in this case, we move the points twice to get the one digit to the left of the decimal place, twice to the left, or we moved the digits 2 and 1 to the right of the decimal point, hence the positive sign. Let's do a second example together. In this question, we are being asked to write 5,432 in standard form. Again, the first step that must be taken is that we must identify the position of the decimal point. In this case, the decimal point will be to the right of the 2 because the 2 is the last digit and is also in the ones column. We will now move the decimal point the required number of times to get one digit only being to the left of the decimal point. So we move the decimal point 1, 2, 3 times. That will leave our number becoming 5.432. And again, 5.432 is not equivalent to 5,432 as it does not have the same value. So to complete our answer, we must multiply 5.432 by 10 to the third power because we move the decimal point 3 places to the left. So there you have it. 5.32 in standard form is equal to 5,432 in standard form is equal to 5.432 times 10 cubed. That brings us to the end of our video. See you next time.